Hello, everyone. Is anybody there?
Hello, good
Hello, how are
afternoon.
you? Good afternoon. Yeah, very good. Welcome to the IEEE ICEIB Conference 2025. And this is the online session D1. This is the online session D1. So I will check this with you again, and I would like to take my hand out and see which one of you will be in the right order, okay, to report the presentation. My name is Wen Zhenyun Zhuang from National Kaohsiung University of Science and Technology. So let's start from the first paper. The title of the first paper in this session is System Energy Management Using Hybrid Utility AC and solar photovoltaics with cloud web application surveillance scheme. The authors are Beltran. Hello, Mr. Beltran.
Hello.
Yeah,
Hi.
hi. The authors Beltran and others are from Adamson University in Philippines, right? So
Hello.
let's welcome them.
Good afternoon, everyone. I would like to share my presentation now. Yeah, I would like to ask everyone if you already see my PowerPoint presentation. Okay, so I
Yes,
think,
yes, okay.
thank you, Professor Swang. Again, my name is Dr. Angelo A. Beltran Jr. I am currently connected with Adamson University. I am from Philippines. And we will be presenting our paper entitled System Energy Management Using Hybrid Utility AC and Solar Photovoltaics with Cloud Web Application Surveillance Scheme. So we are going to start. Yeah, so before we proceed to the uh, discussion proper, I would like to discuss first the outline of my presentation. The first one, I will be discussing about the introduction, and then it will be followed by problems and objectives. Of course, significance, scope, and delimitations will be discussed thereafter, followed by methodology of our research. And of course, I will be discussing the conceptual framework and the results and discussions of our research when we have done our experimental work, and then it will be followed by conclusions. Now, to discuss the introduction, there is a worldwide need to reduce the amount of energy consumption, and everybody has his part to play, whether in industry, transport, business, construction, or at home. And consuming less energy and being more efficient in the way people run in their home will naturally save money and protect the environment as well. Energy production has become expensive worldwide, and its shortage has led to intensified research and development for developing alternate sources of energy, which is clean, pollution-free, and of course, eco-friendly. There is an increasing global interest on conservation of environment. Therefore, renewable energy systems are gaining attention in recent decades and of course in recent years. An increasing amount of research performed in the area of renewable energy and progress was made in construction of such specialized system. In our research, we have done solar and utility AC combined. But of course, when we are dealing with renewable energy, There are other scenarios as well, such as the wind energy, the hydro energy, ocean wave, and so on and so forth. And one of the many ways of saving and controlling the use of electricity is, of course, through the use of the power management and making some innovations. And therefore, knowing the importance of power management and its proper application can truly help conserve our energy. So what is the main problem of our research? In this case, the problem associated with the utility AC are brownouts and power interruptions. Because here in the Philippines, we have a lot of power interruption coming from the AC utility, especially for the islands. And therefore, this is the main objective of our research to really incorporate renewable energy so that we may have a continuous and smooth power supply. The integration of utility AC and renewable energy, such as the solar and other renewable energies and wind, may help provide uninterruptible power supply to the target load, especially the homes and consumers. And therefore, the objective of our study, design a prototype and a power management controller with the advanced monitoring scheme using the cloud for in connection with the solar PV supplied by utility AC. And of course, develop a prototype, not only to develop but construct an actual prototype incorporating the solar energy, the utility AC, and of course the monitoring scheme of the cloud for power management. And also one of our objective is to test the performance of our system. The significance of this study, of course, when we are dealing with energy, it is a great concern, not only for homes, but also for industry, military, and space applications. And of course, the industry and customers, no, from different scenarios, such as in the city, urban, and rural. And without energy, it is almost impractical, no, to really use our electrical and electronic devices because we don't have a power supply to really input it with our electronic and electrical devices. Also, response to growing demand of renewable energy, because we are now dealing with energy crisis nowadays, and renewable energy is very important for research and development. And thus, this makes us provide some energy conservation, and it must be green energy because we should take note of the uh, environmental concerns, no, as well. And it will serve as a guide and test bed for related researchers. So this is the first step of our research, and then it will be followed by succeed research in the future. It can be used as demonstration of renewable energy for educational purpose, especially for high school students, and of course for the incoming college students, and with engineers as well, and thus provide some research avenues and innovations in the future. And one of the significance of our study, of course, in the case of Philippines, blackouts are really happening, especially for the islands. No? Because, in the Philippines, we have more than 7,000 plus islands. And the electrical grid on some islands cannot be really utilized by different islands. And so therefore, renewable energy plays a vital role for this purpose so that the homes and industries as well may provide continuous power supply that is clean, environmental pollution free, and eco-friendly. Of course, the limitations of our study at this point, the prototype consists of a battery bank, of course, the design as well, and the load, and solar energy during the system tests. And we have not incorporated the artificial intelligence. No? such as the neural network, fuzzy logic, in this case, no? But it will be done on the future study. The system should be, of course, one of the delimitations of our study. It must be operated on a dry environment to prevent short circuit on the system as well. And proper connections of the polarity on the batteries, especially for the output of the DC to DC converter, should be observed in such a way that the batteries would not be short circuited. So this is the general conceptual framework of our study. The framework consists of input, process, and output. When it comes to input, we have two types of inputs in this case. We have the solar energy coming from sun, and of course, the utility alternating current source coming from the electrical power utility. And it will be processed by the prototype as well. Of course, when we are dealing with solar energy, the power converters plays a vital role, such as the DC to DC converter, and then the AC to DC converter, and then of course power management system, which we have designed in our prototype, that is consists of several sensors, switches, and microcontrollers, and battery to really supply the excess energy coming from the sun, and utility AC as well. And the DC to AC conversion, which will be directly used by the electrical load, such as the television and even refrigerator or even aircon in this case. And of course, charging our laptops and cell phones and tablets as well. And the chargers and electrical load are normally consist of AC. So in this case, we have the conceptual framework, the input, and then we have the process, and then we have the output. And the block diagram of our research is consists of the following. Of course, this is the general block diagram. We have the source coming from the sun, and then it will be directly connected with the DC to DC converter, flowing the voltages and currents as well, and some relay switch. This relay switch will be monitored by the microcontroller with the help of sensors. And incorporated here is the battery bank. And then in the case of utility AC, yeah, so we have the AC source, AC to DC converter, if in case that our battery requires some charging, so AC to DC converter is needed. And then the relay switch will be done or will be monitored as well by the microcontroller. And then the cloud plays a vital role in connection with the microcontroller, because the cloud really gives us an access, whether you are outside of the prototype, whether you are on any parts of the world, you can really monitor what is going on with the system health of the prototype. And then we have the DC to AC converter, converting DC to AC in such a way that it will be readily applied to the target electrical load, whether it is appliances or even electronic systems for charging purposes. So this is my team doing the prototype of their research, of course, of our research. No? In here, you could see the prototype consisting of the microcontrollers, incorporating the converters, and many others such as sensors. And you could see here the solar that has been currently installed on the house in such a way that we could get some power coming from suns. And not only the electronic design, but we did also as programming as well. Because we all know when we are dealing with microcontrollers, it requires some embedded programming. So we did some programming. Of course, that entails a lot of research and development and teamwork as well in order to finish our corresponding project. So you could also see here that is our corresponding battery bank. And we did some testing using the signal generator. and oscilloscope on the other side. Yeah, this is our team doing the research and development and prototype construction during the design phase. Ayan, so this is our corresponding finished product, experimental work. And this is the design that we did. And of course, we did some documentations, programming, and the hardware design also was done with through the help of electronic simulation. Normally, in this case, we have used the Proteus software to help us really design the schematic diagram and the PCB layout as well. So this is our team. Yeah, so we did install our solar energy on the rooftop. You could see here, yeah, on the upper right, and some posing of our team members. Yeah, so after the construction of prototype and the design of the prototype, we did some data logging with the help of the cloud. And the cloud really helped us monitor the solar voltages with respect to time. In this case, we did some logging. Up to now, the project is still running, no? But we did some screenshots about the data logging of the solar voltage. Although there are some other parameters such as current and power, but for the sake of our present discussion, we did only present the solar voltage with respect to time. So last March 1, we have a time 9:10 a.m. We have logged around 18.3 voltage. So March 2, then March 3, and so on and so forth. We did logging from 9 a.m., estimated different time from different dates for today's presentation. And I also get the data from the lunchtime. Normally at lunchtime, the power of the sun is really intense. No? So you could see here, there are different times at different dates, 12 o'clock noon, 12:10, 12:30, and so on. This is the random getting of solar voltage data at lunchtime. And then we did also obtain some information of solar voltage in the afternoon. So from 9 a.m. and then 12 noon, and of course at 3 o'clock p.m., no? 3 onwards. No? You could see here that the solar voltage is really gave us some intense power, no? During those dates, which is March 1, March 2, March 3, up to March 7. So we have 1 week of gathering data for today's presentation. And of course, this is the corresponding figure, the data log curve of the voltage with respect to time. So the orange indicates that that data is coming from morning, 9 o'clock in the morning. And then the violet, as you could see here in this graph, that is the data coming from lunchtime at different dates. No? And then in the afternoon, we also provided the data log curve based on our previous discussion a while ago. So this is the corresponding data at around 3 o'clock p.m. that was obtained by our prototype during the data logging. So in terms of charging voltage, I just screenshot. Although there's so many data that can be presented, but I just performed some screenshots for the sake of today's presentation. In today's screenshots, I have obtained the data coming from March 1, 2025. This is the charging voltage. So as you could see, 8:15, the charging voltage is 11.96 volt at around 1 hour after, and then 10 o'clock, 11, 12, up to around 2 o'clock p.m. I have here the data, screenshot data for the charging voltage. And the maximum value here is around lunchtime, which is really expected because, you know, at lunch, the intense of the sun or the sun radiation is really getting so much power, no, from the solar PV. And that is why above the rest, the charging voltage is 12.18 with respect to the other data log for charging voltage. And of course, in terms, when we try to graph that one, the charging voltage curve, yeah, this is the corresponding curve. And then the battery voltage during charging, the same time, March 1, 2025. So at this point, the battery is charging. And as you could see that the battery voltage can be obtained with the help of sensors, the voltage sensors that we have connected with the prototype and with the battery as well. So we have recorded the corresponding data for the battery voltage way back March 1, 2025. So in terms of graphical representation, this is the battery voltage curve. That is the voltage with respect to time. And I would like also to show the screenshot of our dashboard, the cloud platform. And this cloud platform really gives us the overall information, like the solar, and then we have the line voltage, and then we have the battery voltage, and other system informations as well, like the description of the prototype, and of course the microcontroller used during the testing of our constructed prototype. In conclusion, power management controller is successfully implemented for the uninterruptible power supply during our testing and integrating our renewable solar energy. And design prototype is implemented at this case, and we have integrated everything from hardware and software, and they are all tested. And so far during our testing, results are satisfied. A separate circuit as well for the power converters had been included in our constructed prototype, like the AC to DC, the DC to DC, and DC to AC. And therefore, these power converters have been integrated with the utility AC, with the solar PV, and with the load in such a way that the overall prototype, constructed prototype, will function as expected. And the test results shows that the design prototype, uh, combining the utility AC and solar, were able to generate uninterruptible power supply. Until right now, the prototype is still working. And we have obtained the different parameters, not only the voltage and current, but also the parameters from sensors monitored right now, no, through the cloud computation or cloud scheme. And with that, that ends my presentation. Thank you so much for listening.
Okay, thank you, Beltran. Thank you, Beltran. And is there any question about their study, which uses the IoT devices, and they are doing the integration? They are doing the integration of software and hardware to be a power management system on the web. It's very amazing. So does anybody has any question? Does anybody have any question? No? So we thank them. We thank Beltran. And the next paper? The next paper is thank you. And the next paper is entitled the study of improvement for embedded firmware emulation applying Firm AE. The authors are from Professor Guo and Wang. from National Taipei University of Technology. Let's welcome them.
Good afternoon. Can you hear my voice?
No problem.
Okay. So today I'm going to share about our research, the study of improvement for embedded firmware emulation, applying Firm AE. In this study, the simulations of Firm AE are analyzed in depth. We propose improvements to adjust the emulation process for different types of emulation failures. The applicable rules in various emulation scenarios are systematized. These improvements enhance the success rate of emulation and provide application reference and technical support for future embedded system analysis and testing. Here are the background. In the recent years, with the popularity of Internet of Things devices, applications such as smart homes, medical devices, and industrial control systems are increasing. However, the security issues of these devices have also become a major concern. In particular, these IoT devices are often found to have a large number of security vulnerabilities, such as unauthorized access, buffer overflows, backdoor programs, memory writes, and more. Since IoT devices often operate in resource-constrained embedded environments, and vendors update and maintain them infrequently, many vulnerabilities remain unpatched in a timely manner. Due to the large variety and number of IoT devices, applying vulnerability detection method with physical testing is often limited by resources. As a result, firmware emulation has become an effective alternative by emulating the device kernel, file system, and hardware interfaces. Testing can be conducted without requiring physical devices. Emulation not only reduces cost, but also improves test coverage and efficiency. This study uses the Firm AE system. Traditional analysis tools such as Firmdyne provide a large-scale emulation solution, but its emulation success rate is only 16%. The main reason is the differences between real hardware environments and emulated environments, causing firmware execution failures within the emulation setup, thereby hindering dynamic security analysis. To address this issue, the Firm AE system introduced an arbitration method, which employs a heuristic-based approach to handle emulation failures. Firm AE was able to successfully execute over 800 firmware images and detect over 300 known vulnerabilities. The figure shows the Firm AE architecture. The executor module extracts the target firmware to obtain necessary information for execution, including the CPU architecture type, the file structure, and directories. The image maker module then processes the extracted file system and data to generate a firmware image, which serves as a necessary file for booting with QEMU. Next, the emulator module performs the first emulation through the arbitration module. During this first emulation, the arbitration module makes corrections related to boot, NVRAM, network, and kernel. Firm AE successfully increased the emulation success rate to 97%, significantly outperforming traditional emulator. There are 4 arbitrations in the arbitration module. The boot arbitration is designed to correct the execution order of init files during the firmware boot process. In this process, Firm AE identifies and adjusts the execution sequence of the init files for different firmware. ensuring that the emulation environment aligns with actual device behavior to prevent emulation failures. In addition to search for init-related files, the boot arbitration also configures common system directories, such as PROZ and var. The network arbitration focuses on resolving network configuration anomalies. During the emulation process, firm AE automatically detects the fixed network configuration errors that may affect emulation, ensuring that the emulating device can properly connect to the network. The kernel arbitration addresses compatibility issues between different kernel versions. Since firmware is typically developed based on various versions of the Linux kernel, newer firmware often runs on higher kernel versions, leading to incompatibilities during the emulation process. To solve this problem, the kernel arbitration adopts the most directly approach by providing a new compiled kernel, ensuring the firmware can execute correctly within the emulated process. Last, the NVRAM arbitration is designed to handle the configuration of NVRAM, as known as non-volatile random access memory, required by the firmware. Properly configuring NVRAM values during the emulation process ensures the returned values do not cause system crashes. In this study, we addressing the issues encountered during the emulation process by following the failure recovery process. In redirect output phase, the original log output is redirected to the command line. This approach allows real-time monitoring of the firmware execution during emulation, making it easier for the study to observe the firmware's behavior. Additionally, it enables us to directly input command line into the command line for interaction with the emulated firmware. In induced rules phase, we will analyze issues encountered during the emulation process and conduct an in-depth examination of these problems. During the repair process, we will evaluate various factors that may affect the emulation success rate and develop corresponding solutions based on different scenarios. The criteria of determining success, including the host side must be able to perform a ping test on the firmware, and the host side must be able to access the firmware's web service through the browser. Last, in the validated rules phase, we will further verify the applicability and effectiveness of the repair rule summarized in the second phase. Next is our experiment. To induce the repair rules, we choose 6 publicly available firmware as experiment data. All of them are publicly available. The first and second firmware were open sourced by the company Delta. The remaining were chosen from the firmware dataset, but all of them were tagged as failed to emulate in the dataset. The first repair rule: when the kernel panics during boot due to init script misconfiguration, we repair on the init parameter with init in the boot command. Use the pre-init shell script for mounting kernel setup and service start. Then run the script file under the etc init tab folder for full system initialization. The second repair rule: when a missing module during system initialization was identified, we download or compile compatible modules, restart the system, and verify proper loading through logs. Repair rule number 3: when the emulation failed due to the insufficient NVRAM support during initialization, we disable firm AE's default NVRAM override or add missing on NVRAM support to ensure correct system call responses. Repair rule number 4: when the system logs show a script execution order error during the initialization, We analyze and adjust strict dependencies and sequence to ensure correct execution order and resolve the error. Repair rule number 5. The system's IP address differs from the default firm AE IP address. We use ifconfig or IP address show commands to check the IP and update network shell script if needed, and adjust run shell script to ensure the host IP is in the same subnet as the firmware. Repair rule number 6. When the bridge 0 and ether 0 have mismatched MAC addresses during the network setup, we remove and recreate bridge 0 setting its MAC address to match ether 0. The last rule, rule number 7. When the firmware's init script auto-configures the network, potentially conflicting with the firmware settings, we disable firmware's default network settings to prevent configuration conflict and ensure proper network function. This is the proposed approach architecture. The component colored in gray is the component we modify. We modify the arbitration, the run shell script, and the firmware image according to the 7 rules. The validation dataset is another 2 firmware. We use this 8 firmware to induce the repair rules. 6 of the 8 were successfully repaired. And we use the induced repair rules to recover these 2 firmwares from the validation dataset. Both of them can be emulated successfully after recovered by the repair rules. Rule number 1 was applied the most with a total of 6 times, indicating that kernel panic during the initialization phase is the primary challenges in emulation failures. This issue is likely related to misconfigured initialization scripts or incorrect system boot parameters. Rule number 5 was applied 5 times, reflecting the high occurrence rate of network-related issues during emulation. Other rules, such as 2, number 3, number 4, and 6 and 7, were applied 1 to 3 times, suggesting that these issues occur less frequently and may arise only under specific circumstances. Here's the conclusion. In the 8 firmware images that originally failed to emulate, this study successfully resolved the issues causing emulation failures and ultimately achieved successful emulation in 6 of them. This study was able to successfully apply the rules derived from analysis and experimentation to the firmware of a completely new IoT device, and ultimately complete the emulation successfully. The last page just showing the emulation failure we have experienced due to this within this research. Thank you.
Yes, and can you hear me?
Yes.
Yeah, thank you for introducing your interesting firm AE system, including the 4 types of arbitrations and the fast testing technology. To detect vulnerables in the IoT devices, right? I think you are Professor Guo, right?
No, I'm his student.
Oh, so you are Wang Yuquan, right?
Yeah.
Oh, so next time, please use your name to log in. Okay, so it's a very good report, and presentation. And is there any questions? Is there any question? Does anybody have any question? No? No? So thank you, Mr. Wang. Thank you.
Thank you.
And in the next, it's my turn to record my presentation, but I will use my pre-recorded video to show my presentation. Okay, so please advise later if you can properly see my presentation screen. Okay, it's a pre-recorded presentation which is has been put on the YouTube. Okay, so I will start my presentation now.
Hello? Sorry, we cannot hear the sound.
While we want to study the facts for gender inequity in employment, or GIE, in the AC industry in East Asia, and the factors for the women employees' labor participation, we launched a large-scale sample survey in Taiwan. During the investigation stage, the total size of the effective sample was guaranteed to exceed 1,067, which is the sample size that an island-wide political polling will have at the very least. A key point of this study is that it was a multi-channel survey, and we used many electronic channels like Messenger, web, and email due to the epidemic lockdown. For the Messenger channel, Line is the most popular messenger tool used in Taiwan. A key point of this survey is that during the survey, we intentionally partitioned the respondents' types into 4 groups. For sure, we keep only the effective sample of 1,349 respondents, and the later analysis will be focused on the opinions of the female worker sample. At first, we can have a chart to check how many respondents are sampled from each channel for each group. And this is the table information for the former charts. Here, we use many descriptive analysis to show the direct results from the survey. And we call these a spectrum analysis here because we want to display the distribution of the answers made to each question. The term spectrum analysis means another thing in physics, you know. We plot many items for the respondent profile, the positive and negative reasons for women's labor participation, and two other mental factors of interest. These correspond to blocks of questions inside the questionnaire. Questions designed for the basic profiles of respondents are all multiple choice questions, which means only one answer can be ticked. One interesting finding is that more than 62% of female workers' current occupations in the industry are normal office staffs or about health and safety. The distribution of age sections of the female sample will concur with a public OSF report later. Here, OSF means Open Society Foundation, and it seems almost 3/4 of them are raising no or two children, and relatively less of them are raising one or three. Raising no children does not necessarily mean a respondent is not married, but a frequent observation in East Asian culture is that companies tend to hire female employees who are single. The wages of women employees will be also discussed later, but it will also meet the situation in other reports. Here, another workplace question allowed multiple ticks. The polling also included the majors and the functional roles of female respondents. These will be discussed later. And these are down for the 10 positive reasons which employees may think to drive female labor participation rate, or FLPR. These are down for the 14 negative reasons to depress female labor participation rate, or FLPR. This is the result for the 7 sources of women employees' self-esteem. This is the result for the 6 types of companions who are currently working with the women employees in the industry. We can give a short summary for the focuses of the whole spectrum analysis here we have made. And these focuses, in fact, correspond to the former 3 blocks of questions in the questionnaire. From now on, we start to compare our results with the facts and what are told in those credible reports. We have multiple sources of those credible reports, and by comparing our results with these reports, we can dissect the factors behind the facts, and we can use the results to validate the facts. See the first figure. The increase in total FLPR in Taiwan has slowed in recent years. See the second figure. For all age sections between 25 and 54, the FLPR increased every 10 years. Outside this middle range, it depends. For 25 to 29, the FLPR in Taiwan is higher than the rate in the US or other Northeast countries such as Japan or Korea. In contrast, for the age sections over 50, the FLPR in Taiwan is usually lower than US, Japan, or Korea. We are interested in the situation in 2027. When we see the AEC or CCE industry among all science engineering industries in Taiwan, it is only ranked 3rd to last. People also call the science engineering industry as STEM industries. And further check the occupational levels that the female workers are employed. The so-called leaky pipeline effect of them is obvious in this industry. The FLPR rapidly decreases with increasing occupational level. This is the situation for E and C of AEC. The situation for A is identical. See the second chart in the lower figure. And there are also formal government statistics detailing the labor participations and the gap in wage between genders. In Taiwan, by reading the relative LPR measure, the gap between men's and women's labor participations had been narrowed down year by year before it came to this decade. But it is still obvious, perhaps, because of the imbalance in the engineering and science or STEM industries. The wage gap between gender has only been improved by a little in the last 2 decades before entering this decade. This is also salient when the wage gap is converted into how many days a woman should work more than men to get the same pay. However, these additional data sets are only available for the entire population in Taiwan. No data is offered individually for the certain industries such as AEC. Now, from the results, we can start to discuss some further findings. So far, there are so many things for us to observe, but the findings and insights can be classified into 3 categories according to the featured topics concerned by the traditional fields of human resource or the gender topics, or according to many questions which will be frequently asked by the practitioner or researchers in the industry. Here we just give some examples. The finding number one, which we write here, is about a time-free observation. It is found that almost all negative factors may depress FLPR, but not all positive factors can drive FLPR. Finding number 2, which can we see here, is a type 1 observation. It is found that the negative factors for FLPR are more pronounced than positive ones. Because all first half negative factors have received more votes than the top positive factor. These 2 findings means that in practice, eliminating and removing the negative factors for FLPR should be a better policy to stimulate the woman group for their willingness to work for the AEC industry. Finding 3 is a type 3 observation. It's found that many current female workers in the industry joined this industry because of some chance. In other words, many of them treat the job as a stepping stone. This attitude has been reflected to many other observations. For example, the relatively low wage of female labor participants and their functional roles in the institution are management-oriented, and administration and business main management roles of them, rather than site management. The finding 4 is a type 2 observation. The low wage situation of female workers stated in finding 3 is a fact that is also investigated by our survey. The average pay for female worker was about NT dollar 40,000 a month after year 2020. Plus the bonus, the annual pay is under 17,000 USD in average. However, this is far below the GDP per capita, which is about 25,000 USD in those years in Taiwan. This links to the report that a female worker must work more than 50 days a year to have the same pay with male. The last finding here is once again type 2. Women do have fewer agentic roles in AEC institutions because from the survey, most of them are office staffs, and most of the places or environments they work are indoor. This concurs with the existing theories or claims made in the literature in other countries. Due to the space and time reason here, these are just 5 exploratory analysis examples. Just see the classification page. There are more exploratory analysis to be made, and we can add more items for each category. And until now, we haven't touched the part of data investigated for improvement initiatives. This is another virgin island for further exploration. Conclusion. We organized and presented the results of a survey conducted for GIE in the AEC industry in Taiwan. We made several interesting exploratory analysis and justified a set of knowledge based on survey data. We also linked the findings with the claims or facts revealed in the existing reports. Except for the words so far, we can continue to deeper studies about the 2 featured topics, or studies to answer those questions. For example, does the measure of female workers matter? Does the leaky pipeline effect really exist? Is it suitable to hire female workers from connection or not? And do women always play non-agentic roles in the AEC industry? Do the mental factors asked during the survey mean anything for other observables in the survey or in other known reports? And except for a similar spectrum analysis can be made for the respondent answers about the improvement measures, some parametric or non-parametric tests in inferential statistics can be introduced to analyze the group opinions of those improvement measures. And that's my presentation today. Thank you for your patience today. This is Wen McGuire, Zheng Yingzhuan from National Kaohsiung University of Science and Technology. Thank you so much. Okay, let's stop sharing my screen, and this is my report today. And does anybody raise a question? Does anybody raise a question for the study about the gender inequity survey, the big data, it can be called a big social data. So if there is not, we will welcome the next one. I think who will make the presentation for the last paper, which is entitled Towards Sustainable Construction, Analyzing Global Climate Emission Patterns through Exploratory Data Analysis and K-means Clustering. This study is from Indonesia and Institute Technology 10 November. So Gloria, will you make the presentation?
Yeah, thank you, Professor.
Yes, and we welcome Gloria Kartikasari.
Okay, I will share my screen. Good afternoon, everyone. My name is Gloria. I'm presenting with Ahmad Khairuddin from Institute Teknologi 10 November, Indonesia. We are analyzes climate emission pattern through exploratory data analysis and K-mean clustering in construction sector. The aim is to identify the key patterns and how to reduce these emissions based on the findings. Because of the ambitious goal of carbon reductions, is pushing industry worldwide to comply with the stricter regulation aimed to reduce emission, particularly contributing to global warming potential. One critical tool that is used is life cycle assessment, or LCA, which helps evaluate the environmental impact products and operation across their life cycle. Beyond the regulatory requirement, market demand is also driving the adoption of LCA, especially as many exporting companies are now required to disclose their CO2 emissions to environmental product declarations, or EPDs. In construction sectors, which accounts around 37% of global emissions, with the sector representing about 85% of all published EPDs, is highlighting crucial and critical role in emissions reductions in construction sector. However, we find there is a significant gap in data-driven analysis of climate emissions patterns, which hinders the development of target emission reduction strategies. Because most existing studies are either localized or focused on individual products, leaving this lack of global comparative insights. Therefore, this research seeks to address this gap by using exploratory data analysis and K-mean clustering to provide comprehensive view of emissions across different products and also regions. The goal is to bridge the gap between the available data and actionable insights, helping the stakeholders make informed decisions for reducing emissions in the construction sector. This research focuses on three main objectives. The first one is to compare emissions across regions to identify which regions contribute the most to emissions in construction sector. The second one, the study explores variation in climate emissions across different product groups, aiming to identify which product groups has highest and lowest environmental impact. The third one, the research investigates relations between emissions, the regions, and also product groups using clustering techniques to group regions and product groups with similar emissions profile. This will be the foundation for developing the standardized benchmarking and also tailoring the strategies. Prior research in environmental data science has largely focused on individual products or companies or industries. Some tools like 3D dashboard using Power BI has been developed for LCA in constructions. However, the tools are restricted to specific building types or specific products that lacks of generalized ability. Additionally, big data analytics has been also applied, but still remain industry specific and need further development for wider user. That's why the key challenges identified here based on the previous literature study is lack of integration across sectors and absence of standardized data. Therefore, this research seeks to address this challenge by utilizing ADA and also K-mean clustering to uncover emissions pattern across product groups and also regions to provide actionable insight for emission reduction strategies. This data was collected from Consultant Indonesia with the EPD document source from EPD International. The data is from 2011 and 2022. It includes around 1,400 construction products from 500 global manufacturers, covering the life cycle stage from raw material extraction, transportation, up to the manufacturing. The primary variability analyzed in this study is global warming potential measured in kilogram CO2 emission for product unit in 1 ton or 1 meter square. And the geographical region included here is Europe, Asia, Africa, America, and Oceania. After data collection, to ensure data quality, the raw data was cleaned using Python to resolve issues like duplication, errors, incomplete and also anomalous data that will be excluded and maybe revisited in the future studies. The EDA was conducted using Power BI to identify patterns and trends across product groups and regions. EDA helps to uncover insights in complex dataset and providing foundation for further analysis. And for the clustering, we use K-means clustering techniques that applies to group regions and product groups with similar emissions profile. And this result optimized with the silhouette score and also index to find the high and low emissions cluster. And this methodology helps identify the key areas of targeted strategies and interventions for climate emissions. This shows the distribution data of our data collections from the locations. We can see that around 69% comes from the Europe that has been forefront of calculating and disclosing climate emissions, reflecting its maturity and also commitment to sustainability. However, we can see as well the next is Asia. We see that Asia is already growing contribution in the climate change calculation as more countries in Asia adopt emissions calculation to respond to European regulations. And the other regions like America, Oceania, and Africa represent smaller shares. However, these trends indicate that while Europe already leads, however, regions like Asia are rapidly catching up with this calculation. And based on the product group, this shows the distribution of data collected. We can see that most around 20% comes from concrete, cement, and plaster articles, followed by iron and steel products, and also board and panels. And in total, the study covered around 28 product groups with 74 subclasses across construction sectors. This will offer comprehensive analysis of emissions across various products. This is the result of average climate emission for the construction product by regions. We can see that from product measured in 1 ton, Asia and Africa is the highest, followed by Asia, Europe, and also the America. The highest emissions come from the aluminium from the Mozambique in Africa, and also followed by the other country like Saudi Arabia and Greece. While the lowest emissions come from the concrete and cement articles, comes from the country-specific Romania, Brazil, and Ireland. If we see from this product for the square meter, Europe leads with the glass products from Poland and Switzerland with the highest impact. The second one is Asia. It comes from the manufacture of semi-manufactured plastic for construction in the South Asia that contribute significantly. On the other hand, these results break down the highlight that regions has difference in emissions, with specific product groups also contributing based on their production practices and also energy sources. This result shows the emissions per product groups, and also the left table shows per ton of products. We can see that semi-finished non-ferrous products has the highest emissions, followed by also semi-manufactured plastic and other metal products. On the other hand, the lowest emissions come from concrete, refractory, and aggregate and bitumen. The second table shows the highlight of the 10 top subclasses product with the highest emission, which is the top one comes from the aluminum foil. And then the next, this result is for the product per square meter. The highest contributor of the climate emissions comes from the glass products, followed by the non-ferrous and also the building finishing surface. And on the lower end, it comes from the chemical for constructions, plaster, and also paint that show the least emission. And this one is also the second table shows the top products with the highest emission, which is the first one is the glazing and also the glass products. And this is the results of the clustering analysis. Identify that the highest emission regions after removing the outliers. For products measured in 1 ton, the regions with the highest emission are this one, Australia, New Zealand, and also Eastern Asia, with the average of the climate emission is around 2,600 kilo CO2 equivalent. And while looking for the lowest is in here, this cluster from the South America, European, with the mean average of the emission is around 300 kilo CO2. And while looking for the product with the square meter here, the Southeast Asia emerged with the highest emissions cluster. It's around 300 kilo CO2. And then the lowest emissions come from this cluster, America and also Europe as the least, with the mean around 33 for the product in square meter. This Cayman clustering results have to identify which key regions needs to be targeted of the decarbonization effort. And this slide shows the Cayman clustering results by product groups. Based on the emission per ton, the analysis resulted in 4 clusters. The highest emissions come from cluster 2 here, having mean average about 3,200 kilograms CO2 emissions, while the lowest emissions come from the cluster 1, which is this one, around 270 kilo CO2 emissions. The product groups you can see in the table is include the semi-finished non-ferrous product for the highest emission, but for the lowest comes from the cluster 1, which is comes from the aggregate and also bitumen. And the next is Cayman clustering result for product group per square meter of product. This analysis resulted in 7 clusters, with 4 clusters showing the highest emission, with mean around 647 kilogram, and the lowest emissions come from the cluster 3 that has average around 24 kilograms CO2. And from the highest, cluster 4 includes the emissions from the semi-manufactured plastic and metal products, while the cluster 3 again it comes from the plaster, paints and also cement, which shows the lowest impact. And as the summary, the finding of this research are Africa and Asia shows higher emission that likely due to the energy intensive process and also less advanced, while European, specifically Northern and Eastern, dominate low emission clusters. And in terms of product groups, glass products and semi-non-ferrous products, which is actually the aluminum foil, are the high emissions material that require targeted interventions, such as using carbon taxes or subsidies for renewable energy. On the other hand, aggregate and bitumen show lower emission that could benefit from preferential treatment under CBAM or carbon border adjustment mechanism. And this result also shows that there are variations in emissions complicate the industry worldwide benchmark, driven by many differences in energy sources and also technologies. And the implication is for policy and also the industry, we need the collaboration between low and high emission regions, which is crucial for knowledge sharing and also technology adoptions. Policy should also focus on high emissions products by giving like incentive low carbon material through subsidies and taxes, and also encouraging for green technologies. On the other hand, policy should also target high emissions product groups for their decarbonization through financial incentive and also taxes, and should foster investment for the green technology in the region with the high emission to achieve global sustainability goals. As a conclusion, the key insight of our research is we provide a valuable understanding of climate patterns across regions and product groups, and highlighting the needs of high emission regions to collaborate with the low emission region to share their best practice and innovation for decarbonization effort. And high emission product groups like the glass and also the non-ferrous should be prioritized for innovation and decarbonization effort, because the decarbonization strategy emphasizes that targeting high emissions cluster for using like carbon taxes and subsidies and investment in green technology. And for the further research, we identify that we should focus and identify more about the root causes of emissions variations, including, for example, technology gaps and energy sources, while also exploring circular economy practices to further emissions reductions. And finally, for the policymaker implication, should consider this insight when designing regulation to ensure they account for regional and product-specific emission profiles to give fair and effective carbon adjustment. And this is our reference. Thank you for your attention and listening to the presentation. As this research is this early stage and the data is can still evolving, we will continue to update. And however, this research give the foundation of analysis to provide the logical framework for the future. Thank you.
Yes, very good. And thank you for Gloria for her presentation. And this study actually makes an analysis for the information of emission data globally, right? And the analysis uses exploratory descriptive analysis using Power BI and conducts the k-means clustering to understand the grouping effects around the world. It's a very good study, and the cross regional, you compare those results cross regionally, and it's interesting. The study goes from data collection. What my comment is that the study goes from data collection to data pre-processing to data analysis and prediction, the prediction phase, because you have used k-means clustering, so it counts for a method in prediction. It's very complete. It's a very complete study. But what I think, I have only one comment. Is that maybe you can consider to rephrase data collection, the term data collection with replace it with data pre-processing, because data collection it's data cleaning, sorry, that you can replace the term data cleaning with data pre-processing. It will be better because it's a subdomain of data pre-processing.
Okay.
Okay. Thank you so much.
Thank you, Professor Chuang.
Yeah, no problem. And that's our session today. And I sincerely thank every one of you who joined this session. Thank you.
Thank you.